Okay, welcome back everybody. This next segment is going to be about how do you, in essence, and I'm still sort of working within the book, how do you read and interpret a contingency table? So note to self, contingency table. It's basically a 2 or 3 or 4-way table, a table that displays you have categorical variables as your row variables, categorical variables as your column variables, and these various numbers, right? So for us, because of the time that it takes to construct the bar charts and all that, and since we don't have our Excel when we're taking a test, really I just want you to be able to interpret and construct certain distributions, not necessarily draw out the bar charts and all that. So let's just start reading this problem. We have employment status. That would be called your row variable. So employed, unemployed, or not in the labor force. We have level of education, didn't finish high school graduate, some college, or bachelor's degree or higher. This is from the Bureau of Labor Statistics. Okay, so we have a table, two-way table or contingency table. You can see that here. Okay. Now what the author's going to do is they're going to ask us to create certain things, marginal distributions, conditional distributions, and what does that mean and how do we do that? Remember when I said that anything important in the book was probably in a magic box? And it is. Here it is. A marginal distribution of a variable is a frequency or relative frequency distribution of either the row or column variables in the contingency table. Let's take a look. Now, what you're going to notice is one of the first things you want to do with your contingency table, whatever it may be, is you want to get your column totals. So, by the way, this here is a column total. And you want to get your row totals. So here is a row total. Okay. First thing you do is do that. Then, the next thing that we're going to do, oops, let me erase that stroke there. Next thing that we're going to do is determine what's called a relative frequency marginal distribution. And you can imagine it's going to involve these numbers that are in the margins. Now, one number to focus on is this 218,000. Okay, what that means, the table indicates that there were a little over 218,000 U.S. residents, 25 years or older, that were sort of polled or used in this survey. Okay. Okay, so the first thing I want to do is take a look at the kind of thing that we'll have to construct, say, on an exam. And the language is actually the difficult part. Doing it isn't that bad. So here, determine the relative frequency marginal distribution for level of education and employment status. Keyword is marginal, so you know that you're going to be using these numbers that are in the margin. Bear that in mind as I flip to the next slide. Okay, so first thing you're noticing, remember those row and column totals? You're noticing right here, what did we do? We divided it by the total number of people that were surveyed. So 14%, 31%, 25%, 29%, and then we did the same thing in the column. So long story short, to construct a relative frequency marginal distribution, you're just taking those numbers that you had you're taking your row total and your column totals respectively and dividing it by the total number of people that you surveyed or that were polled. Okay? Now, the big question, why would somebody do that? What does that tell us? Well, here's a great example. By doing that, we can see that 14% of U.S. residents, 25 years or older, did not graduate from high school. See, what we've done is it's easier to work in percents and draw the eye to a statement like that, because what we've done is we've taken all those people that did not graduate from high school and divided by the total number that were surveyed, and now we can make a statement. 14.6% of the U.S. residents 25 years or older did not graduate from high school. We can say 56% of the U.S. residents 25 years or older were employed in 2010. And you say, now I'll grab a different color. You say, well, where did you get that information? See, that's what you can get from your row total. See, because here's the employed. So what we see here, by taking your row total and dividing it by the total number in the sample space, you can make a statement. So now you can say, 56% were employed in 2010. All right, so it just gives you a way to make statements about your table. Okay. All right, let's try the next one. Okay, so again, anything in a lovely box here. Conditional distributions list the relative frequency of each category of the response variable given a specific value of the explanatory variable in the contingency table. And I know those kind of definitions in stats books they sound vague, right? So the best thing to do is let's work an example together. Okay, so let's focus in on the kind of language that is going to be used on a test. Okay, right here. So it says find the conditional distribution of the response variable employment status by level of education. So look out for that kind of language. Find the conditional distribution of something by something else. Whatever, I always tell people, whatever follows the word by level of education, that's the thing you're dividing by. That's how you can remember it when you go to construct this. You're going to see this in a moment. So just remember, we're doing a conditional distribution of employment status by level of education. Now you'll see what I mean. The way I remember it is it said by level of education. So notice what you're dividing by in every cell. So here you're dividing by the total. So you see that? The total number of people who did not finish high school. So that's by level of education. Here, you're dividing by the total number of people that were high school graduates. Here you're dividing by the total number of people that had some college. And here you're dividing by the total number of people that had a bachelor's degree or higher. So when you say by level of ed, make a conditional distribution by level of ed, that's what's going to trigger you for what you're dividing by. So you're taking each cell entry, the 9993, and then you're dividing it by something. And that something, happens to be the number of people in the level of education. So if you resort back to our original table when we originally got our row totals and our column totals, you'll notice that the 31,768 is the column total for, those that did not finish high school. And, you'll notice that the 68,214 is the column total for those that were high school graduates, okay, et cetera, et cetera. So this, a lot of people say, oh, is a conditional distribution something really difficult? No, here it is. The conditional distribution itself, it's these decimals here that you're interested in. So getting those is not hard. You just have to remember what you're dividing by. But the most important thing, I can't stress this enough because of what we do at the end of the year, is how you interpret. So you say, why would I make this conditional distribution? Well, let's just take an example here. Let's interpret what we see here, this 0.705. That basically means if it's a conditional distribution, we can associate that with the probability. So, the number on the denominator is your level of education. So given that someone has a bachelor's degree, so I'm going to interpret that. Given that they have a bachelor's degree, what's the probability they're employed? 71%. So I like to say like that. Given bachelor's, I'm going to say, well, there's probably about a 71% chance that they're employed. So it basically that's why you hear people during presidential elections making all sorts of statements based on data such as this, right? Or for example, given that someone did not finish high school, what's the chance that they are employed? Okay, well, notice, look, that's a lot less, 32% chance, all right? Or a different way to ask that would be, given that somebody had a bachelor's degree or higher, what's the chance that they're unemployed? And luckily, for you guys, it seems well for you, it's only 3% chance, right? So it's like, given that I have a bachelor's degree or higher, what's the chance that I'm unemployed? And that's unlikely. But like I said, nowadays people with PhDs can't find jobs, so hopefully that'll change in the near future. But the big thing is I hope you're able to construct these tables and interpret them. Okay, good luck.